Hi there. Welcome to the Food Chase training. Today we'll have our module number 3 of the Smart and Sustainable Food Production System. And the sub-theme that we'll be talking about today will be the real-time monitoring for efficient food operation. I'm Professor Rafael, and I hope you enjoy this class. Let's go to our class. By starting, we share with you the learning outcomes, which has been divided in 5 different ones. You will see it in the front one of the first pages of the written material, and you are always welcome to read it, and actually more than welcome. You are advised to read it and explore the papers that I have shared, the link of each of the papers and the articles. Some of them are very updated, which will help you a lot understanding and dive deeper into such a subject, okay? The outcomes, as I said, we have divided in 5 different ones. Understanding the role of real-time monitoring in reducing food loss and inefficiencies. You will see again, food loss reduction is always at our top priority here. We never avoid, but we looking at reduce. The second one is identify interpreted KPIs in food production systems. Explain how sensors and data acquisition systems support food safety and quality. Apply monitoring concepts to preventive and predictive maintenance strategies. Remember those 2 different typologies, preventive, predictive. And use real-time data to support operational decision-making and process continuity. Let's start. Introduction to such a submodule. Operational inefficiencies, delayed failure detection, and process instability are major drivers of food loss, energy waste, and economic underperformance of agri-food systems. We call it agri-food systems because these operational inefficiency are not exclusive to the food industry, to the food factory, not the industry, the food factory itself. It begins on a farm and finishes on a supermarket. And that's why it's the main failures, the main problems, okay? And of underperformance of our agri-food systems. But we keep our eyes open to understand and to decrease and mainly food loss and energy waste, okay? In the EU, European Union, compliance with hygiene, traceability, and sustainability regulations requires continuous operational control, not only endpoint inspection. The real big difference, I don't do my homework, my business as usual, and check at the very last phase or the very last step. Never. You will start monitoring, and each of the phases you should be monitoring. You remember from the first class, the KPIs, it must be watched in each step to avoid losses or decrease losses, decrease energy waste, and etc. Okay? Real-time monitoring enables, as I said before, producers to detect deviations early, maintain stable processes, and prevent avoidable losses across processing, storage, and packaging stages. Okay? Very key to it. Foundations of real-time monitoring and food production. Here at the right-hand figure, we have the MES and SCADA. MES stands for Manufacturing Operations Management, which is comprised of scheduling of activities, production tracking, understanding in which phases, quality control, and more. Why we call it more? Because it depends on the type of industry you are. MES is applied not just for the food industry, but different industry, and that's why I call it more, because you can put some new indicators, new KPIs into your thing, okay? And SCADA, SCADA, which is a monitoring and supervision, real-time monitoring and control of specific equipment. This is very important because it's a type of a digital platform that help us understanding how our factory, in this case, just give you an example, a simple example, how a factory works in each of its stages, or what's happening on the reception phase, what's happening on the trimming phase, what's happening on cooking phase, and etc., on the packaging, etc. So SCADA helps us a lot by monitoring and supervising, okay? The real-time monitoring integrates sensors and data acquisition systems. We must put the data of our production to something and be able to access it. Digital platforms, as those I have mentioned, MES and SCADA, key performance indicators and performance metrics to understand what's happening in each phase, and decision support and alarm systems. I don't want to find out that my system is not working properly on canning, example, by the end of the process. I want to understand how it is not working well, and that's why I have here decision support and alarm system. Okay, its objective is to convert raw material operational data into actionable insights that reduce variability, waste, and downtime. Use technology in our favor. Key performance indicators, you have seen these before, but they structure complex production data into interpretable metrics and are typically grouped into. Remember, you have a lot of information around, like this graphic on the right-hand side, but you want to understand how to interpret and take a decision based on that, okay? And that's why they're grouped on productivity, KPIs, quality KPIs, equipment KPIs, energy and resource KPIs, and maintenance KPIs. Together, these KPIs enable early detection of inefficiency and losses. On the written material, you can go deeper, I think 2 or maybe 3 paragraphs long, maybe more, for each of those typologies of KPIs, okay? But the main idea of KPIs are to enable early detection, early warning system of inefficiency and losses, okay? You don't want to find out when your product reaches the supermarket. You want to find out at the beginning, okay, of a process. You know, this is very desirable. And the role of KPIs in waste reduction, just giving you an idea. This is a type of Power BI on my right-hand side that you can see the maintenance duration, the production duration, and etc. You can actually, this is an example of what's going on here, specifically on minutes lost by line. You see that if you are able to understand, interpret such a data, you can act very quick accordingly and avoiding problems at the end of your line, okay? The real-time KPIs, they help you what? Visualize, identifies bottlenecks and hidden losses. The graphics just helps you. Link process deviations to quality outcomes. You see that if your line is running 1 minute later, what's be happening with the quality of a product? Maybe you will not be canning properly at the end because the line is not working accordingly. It's not rhythmic, it's not converging, it's not synergistic working. That's why this is so important. This type of real time, we call it real time because you are looking at it happening now. That's why I call it real time. Reduces escalation of minor issues into major failures. Remember, a small problem here can become a huge problem at the end of the day. Real time helps you avoid that or identify and act accordingly. Supports continuous improvement sustainability targets, and KPIs are foundational for operational resilience in food manufacturing. Very important. Sensors and data acquisition system, another chapter of our document of module 3. Again, we have some examples of web application of a sensory gateway and sensor node. This was a publication of MDPI, which is a journal, scientific journal of food, specifically on the food industry. And it's the link for this is right on the written material. You can access and dive deeper, but these are examples of sensor and data acquisition system that help us understanding the system and take the action on the right time, okay? Modern food production relies on integrated sensor networks monitoring, like this one here, which temperature and humidity controls temperature, humidity, flow and pressure. Imagine have a system of a pressurized air that you need to cool or maybe to heat up. If you lose such a pressure, you can lose the entire batch. These sensors help you understand where the pressure is losing or maybe having more pressure than desirable and etc. Okay? So these systems, they reveal something that normally we don't see on eyes. Okay? Vibration and acoustics, equipment condition, such a system help us understanding if it's working well. And the acoustics here, if it's emitting higher noises, which will cause harm to the workers, this helps us a lot as well to avoid problems with labor safety, etc. Okay? Optical and vision system, defects, contamination, package integrity. Our eyes, sometimes they cannot see things that the machinery they can see, they cannot. And that's why it's so important. Energy consumption, very key. How much kilowatt hour are you using to produce this product? These things can track back and understand in which phase is consuming more energy, which phase are actually not consuming energy for some reason, and helps you taking action. These systems provide high-resolution continuous data. Remember, continuous data is directly connected with real-time monitoring, okay? Because you don't have to wait the thing to happen at the end of the day to say, now I understand what happened. No, the real-time helps you understanding as it goes, okay? SCADA and MES platforms I have mentioned before. I'll just give you an example. SCADA systems for real-time control alarms, and MES systems are more used for linking production quality and maintenance data. Those two platforms, what they do, they enable rapid intervention, remember, real-time intervention, real-time decision, improve traceability and audit readiness. What does that mean? Improved traceability and helps you understanding where the problem is. Example, you know that that machine is not working well, but which part of the machine? Those platforms can help you understanding the sensors and act directly on the problem, okay? And help audit readiness. Those SCADA and MES helps organize the data. If I have an external auditor checking my industry for some certification, with the system, he can just jump on the system and understand what's going on, what's working. Helps a lot on transparency. And reduce unplanned downtime and food loss. Okay, these systems are always looking at decreasing food loss and unplanned downtime. Okay, monitoring production performance in real time. Again, real-time monitoring enables immediate detection of. These are one of the examples, okay? Temperature deviations outside validated limits. Remember, we have limits for cooking, we have limits of machinery operation, etc. Irregular flow rates affecting lethality, okay? Lethality of microorganisms that normally existed in our environment, okay? Helps us understanding that, which is very, very technical. Drops in throughput indicating bottlenecks, very important, and increase in defect rates signaling instability. Those systems, if they notice the increasing, they will be signaling instability. The system is not working well. Why? Where should we act? These systems helps us. That's why monitoring on a real time is so important for us. Early intervention prevents quality downgrades, reprocessing, which is very costly, and disposal, which is the worst situation once. Okay? The HACCP checklist here on the figure is linked. There is a link for this on our written material. I firmly believe that you must read that. It's a must, you know, because HACCP is something very applicable and you see on everyday work if you're working on the food industry. Okay? Food safety and regulatory compliance. Here, there is a legislation for you to understanding the prerequisites under some ISO standards, some legislation, etc. for European Union. And the main objectives of continuous monitoring is strengthening HACCP verification, okay, the hazard, to understand where the hazard is and how to act accordingly. Traceability in audit documentation. Remember, if you can trace back, you can understand where the problem is. And the audit documentation, if you have a problem with something, example, the batch that has been sent to the supermarket got some problem, we can do the auditing by checking the documentation because those systems are all clear and transparent. And helps you find the root cause analysis during deviations or recalls. Remember the recall from supermarket? This is an example. Helps you understanding the root causes of it. You don't departure from nothing. You actually start understanding where your system failed. Okay? Automate alarms reduce reliance on manual checks. Remember, the manual checks are performed by humans. Sometimes we are tired. Sometimes something happens with the human, with the worker, with labor. He's not properly trained, or maybe he's tired. And this results in some mismanagement. And this automated alerts reduce reliance on manual checks and minimize waste caused by delayed responses. Machinery tends to give a real-time responses, which helps a lot taking the right decision, okay? And the next theme, equipment performance monitoring. We have the 5 on the figure here, the 5 most common causes of equipment failure. Okay, age and usage, improper operation, has a lot to do with the training, staff training. No real maintenance plan, that's very normal. Too much maintenance, a lack of equipment monitoring. Okay, this paper, again, this publication is from a page itself. You can check there and dive and explore each of those 5 main causes. It's extremely recommended for you. And the equipment failures are major sources of production interruptions, you have to stop your line. Product spoilage, very undesirable of losing what you have actually have bought it, you have produced, you don't want to lose it. And energy and resource waste. Remember, it's a step, just stacking problems. You avoid it. That's why we do equipment performance monitoring. Real-time monitoring tracks indicators such as vibration, temperature, pressure, and energy used to maintain stable operations. Okay? Preventive and predictive maintenance. Now we have a comparison here for you to understand the difference. You see the graphic of a service now here, but I start with the left column. Monitoring enables a shift from reactive maintenance that respond after the failure. You have a failure, already happened. That's why we call it reactive. You're just acting after the thing happened. And when we monitor, we'll be able to change from reactive to preventive and predictive maintenance that work under anticipated failures. Anticipating the potential failure. I don't want it to happen. I look beyond it. Okay? This approach, reduce unplanned downtime. I don't have to stop my line. Preserve process continuity. You have something flowing. And minimize food loss during stoppages. This graphic here just shows the difference between preventive versus predictive maintenance and compares to reactive maintenance. You see the difference of cost, you see the difference of number of failures, okay? You see the repairing cost just going up. Here, as far as you go to reactive costly turns, same happens to the total cost. We always increase in reactive, okay? And the preventive cost is small and reactive because you haven't done that. But this graphic shows you where to act. You find the better point here to act accordingly. Okay? OEE and digital dashboards, very important. Real-time OEE dashboards review hidden losses. These are type of a Power BI that is a Tiolytics, is a type of analytic. You can see the direct labor, the availability, downtime, planned downtime, unplanned downtime. You can actually see the cause of unplanned downtime. You can check, you have the indicators. You can check what this indicator is composed of to understand what you have to act to decrease the problem you're having. Because it reviews hidden losses, such as micro stoppage and speed losses, because it actually opened the black box for you to understand. Enable comparison across shifts or line. You have 2 or 3 different lines working. You understand in that which one is working. If there is a problem, if it's a difference between lines, something's not correct. If the line's supposed to be the same, working the same rhythm, you can actually understand what's happening in that. And support data-driven improvement decisions. This data will help you take the decision and helps you under an audit or maybe under certification scheme to prove, look, I have the data here. I have taken such a decision based on this data. This helps you a lot. And digital dashboards integrate production, quality, and maintenance data, supporting cross-functional collaboration. This thing here is very important, cross-functional collaboration. Because remember, you have quality data, maintenance data, production data. You have different data that normally are separate into one system. That's why dashboards are so important. The digital ones are so important because it helps you understand. Sometimes you think the problem is here, but actually it's not here, it's there. If you don't look on the broader view, you won't be able to diagnose it. And that's why digital dashboards are so important, okay? This was the module number 3. This figure here, I have shared with you the link. You can click on that and go to the page and explore the OEE and dashboards, as well as those previous concepts I have shared with you. This presentation is very quick, supposed to be quick. I don't want you to be overloaded with information, but this is just an introduction to each of the themes we have touched on the module 3, okay? The exercise will help you fixing the knowledge, and the supporting material will help you understanding more, having some examples of a case studies and etc. Okay? Thank you for your time. I hope you have enjoyed this class, and see you on the module number 4.